Okay, we'll go ahead and finish up on the list interface. Last time, let's just quick recap on what we were doing. Ooh, lights. Let me check the light. Better? All right. So we could create an array list, and we can just call it a collection C. Just to recap, because we need to make sure all this is crystal clear, what is that line of code doing that I've just highlighted? Anyone?
Creating a collection, right?
Okay. It is a type of collection, yes.
Yeah, like of array.
Okay, it's creating an array list. Where is that array list being created? In the heap, all right. So that's what's happening on the right side from new array list. And what's collection C equals do?
Creates a point.
Creates a pointer to a
Array list. Or to a memory location.
it's to a memory location. It's not to an array list. It's to a just to be what type is C? You were close. Collection. So C points to a collection. We create an array list, which is a collection. Therefore, C can point to it. Since C is collection, it has an add function. We can add, looks like it added a bunch of integers from 0 to 100. I created another collection called C2 from 50 to 149, add them. Then I showed how you can use an iterator, C.iterator, which gets the iterator, and do has next to print them all out. Then down here, what does this interface do? So this is going to be a little different. We've been using generics, but I haven't been explaining them too much. But anyone want to take a guess? What is that line doing? We'll start there.
It's taking the index of the list integer and creating a new linked list.
Oh, okay. I see. Okay. Good guess. So new linked list, what would that do? It would create a object linked list on the heap. I'm only iterating this because a lot of people get confused. So it creates a linked list on the heap. Now, we're using generics of integer. Of integer. So iList is going to point to a list of integers. That's what that bracket's the less than greater than sign. You're specifying what the list is of. Beforehand, you did not specify what the list was. Up here, you did not specify what the collection was. We could have, but we didn't. Down here, we're specifying what the list is of, and it's of integers with a capital I. So iList is going to point to a list of integers, and we're going to create a new linked list, technically of integers, on the heap. And then for int I to a whole bunch, we're going to add to it. And then here's where I had a sum, and I showed you if I use the iterator, it prints it out really, really fast. So we'll go ahead and we'll run this. Doop. But if I did not use the iterator, and I used our for int I, it would take, well, it's still running. It would take a very, very long time. Notice that the process is not completed. It's still trying to sum it up. All right, any questions on this code? Any at all? Go ahead and revert it back. Nothing? All right. All right, so the list, it has all the operations from a collection, plus it's going to add a couple more. There are two implementations for list, well, two common implementations, I should say. One is linked, which gives you faster insertions and deletions, and array list, which gives you faster random access. You notice from that code we were doing random access with .get. That's why it was so slow, because linked list is very slow on random access. But if we were trying to add and remove a bunch of items, a linked list would be faster. And it is poor style to expose the implementation, so you always want to do list equals new linked list, not linked list equals new linked list. Everyone good with the good versus bad? All right. So .remove removes the first element, E. Add and add all, add to the end of the list. So if we were over here, do we do a remove? Oh, we didn't do the remove. So if we were right here and says, does the list contain 999? We can do ilist.contains. And we do ilist.remove, 1, 2, 3. And then print out, does it contain it? It'll actually, should print out false afterwards. Right, so it contains 999, we remove it, then it no longer contains it. So remove is going to remove the first element of that. In other words, if you have a list that contains, let's go make this on the board. Okay, so if you had a list of 4, 3, 6, 4, 10, and you call .remove of 4, what would be your new list? What would be your new list?
Would it be 3, 6, 4, 10 because it only removes the first?
Right. 3, 6, 4, 10. All right. Just want to make sure that's clear. With the regular remove, it just removes the first element it finds, starting from the beginning. On the other hand, well, I believe there is a remove all if you want to remove them all. Add and add all adds to the end of the list. To append the list to another, you can actually pass one list to another. To append two lists into a new list, just create a new list of the first list and then add all. We'll actually add all the lists together. Do you want to see an example of this, or?
Yes.
Yes. You want to see it on the board?
Sure.
Sure. All right. We'll have this be list 1, and then list 2 will equal, I don't know, give me some numbers.
17, 33, 14.
All right, that's good. I don't want to write too much. So if we do new, oops, let me start over here. What is causing this glare?
The light outside.
Oh, the light. All right. Now I know where the glare is. So if we do list of integer list 3 equals new, well, we'll make it a linked list this time. List, and we'll pass in list 1. That means that list 3 equals, what is it going to equal? So it's we haven't done copy constructors. I'm sorry. By passing in list 1, it's going to copy all the contents of list 1 into the new list 3. So it'll be 4, 3, 6, 4, 10. So list 3 at this point would be a copy of list 1. Now they're two separate objects, but they both contain the same information. All right? Now if you do list 3 dot add all of list 2, it's going to append list 2 to the end of list 1, which means that list 3 is going to equal, all right, what is it going to equal?
List 2, list 1. Oh, yeah, list 2.
What will be the first number? 4. You have it, just loud and proud. 10, all right. 17, all right. 14. All right. Any questions? Great. See, you can always get at an index. So let's see if we know how to do this. List3.get, which again is just the same thing as with an array list. We'll do 5. What number should that return? 17. 0, 1, 2, 3, 4, 5. All real programming languages start at 0. You can also set it. So list3.set at position 5, comma the value 4 implies that list 3 is now what? 4, 3, 6, 4, 10, 4, 33, 14. Because it's like the subscript on an array. So you just call sub, you set at, let me make sure I said that right, set at a position, yeah, index and value. So index 5, which is that 17, with the value 4, so that 17 became a 4. Okay? Yes?
Could you do list3.add all and then give it list 3?
Yes. And then you would just have that list followed by the list again. Good question. All right, so add will actually add to it. How are we doing with this board? Good, we still have room. List3.add. We'll go ahead, we'll go with 3 this time, and we'll put in 100. That implies 4, 3, 6, what did I say, 3, so 0, 1, 2. Then you have the 100, and then it continues on with the rest of the list. So 4, 10, 4, 33, 14. That's a 14. See what I did there? If this list was an array and you wanted to do this, what would you have to do?
You have to iterate through it, right?
Yeah, you'd have to increase, make sure the size is high enough, copy everything over, and then put the 100 in. If your list was 1,000,000 long, that'd take a long time. A linked list just does it better. Okay, and you can remove an index. I'm about ready to erase all this because I'm out of room. Any questions on this? Nope. Any questions on this? Nope. All right. I'm going to erase it all the way down. Okay. So then if we did list1 dot remove, and no, it's not hold on. Make sure. Remove, add an index. Good. So you're moving at the index. We'll do index 3. That implies that your new list is 4, 3, 6, and then 10. Because it just got rid of the 4 and shifted everything over. Good? All right. Doing great. So if you wanted to add everything at a particular index, looks like you can do it. Oh boy. Some of those operations are more efficient with the array list. Searching. So if you want to do index of, you go list1 dot index of, and we'll pass in 6. What value should that return? Index of is going to give you the index of where that value exists. So that should be 2. You did list1 dot index of, and we'll say 99. Since that is not in the list, the answer will be -1. So you can actually use this function to find out if a value is inside the list by just doing an index of the value, and if it's not -1, you're good to go. It's in there. Last index of. So index of gives you the first one. So if you did index of 4 on this one, it would return 0. Oops. Index of on this one, just of this guy at 4, it returns 0. If you did last index, it would return 3. We haven't talked about equals and hash code, but we'll get to hash codes later. All right. I think that's enough with the lists.
What was the code for changing a value in index? Not adding.
But setting it?
Setting. Like
So that's setting.
Changing, leaving the same number of values, but changing the 6 to 2.
Yeah, so that's set. That'll actually set it at that index. Add actually puts it in and moves all the items over. All right. Okay, let's see. I think that's enough for lists. So I'm going to stop there.
I got a question.
Yes.
Does remove only work for one integer at a time?
So the regular remove does. And if I recall correctly, let's go ahead and look it up just now. So Java list, there should be a remove all function. So if I'm in here and I have a remove all contain, so that's not what you're looking for. So it looks like right now you can only remove the first occurrence. So if you want to set up a piece of code to remove all of it, notice that remove actually returns Boolean. True if the list contained the specified element. So you could really just make it a while loop, while remove 4, and then it would just keep removing 4 until you were done. So in other words, let me show you that code. So you're up here, and come on, come into focus. There we go. And we did while list1 dot remove, and we'll say the new integer 4, and that's only to specify that we're trying to remove the actual item 4, not the 4th index. And I like to put in my curly brackets with a semicolon. So what that does is, it goes in, List.remove of 4 finds a 4, removes it from the list. It returns true because it was in there. It's going to come back to the while loop, remove 4 again. It finds it over here, removes that one, returns true, loops again. Remove a 4, well, the list is only 3, 6, 10. It's not in there, so it'll return false, and then you're done. So this piece of code, when it's done, will do 3, 6, 10.
So you can pass remove an object or an index?
Right. So there's, if you go over here, this is good. Let me see, where did remove go? All right, notice remove has an index and an object. Index removes the element at the specified position. So if you pass in an integer, it's going to go to that position and remove it. Remove on an object actually finds that object and removes it.
So if we're trying to remove a number from a list of numbers,
So when you do a list can only be contained of objects.
right? Okay.
Therefore, new integer, that is the object, a wrapper around the actual integer primitive. So by doing this, I'm forcing it to become an object named 4, as opposed to just passing 4. Is that clear?
Yep.
Yeah. It's actually really important to understand, because I'm forcing it to be an object, therefore it's going to search and call one function over another. Any other questions? Wow, these are good questions. All right. Okay. Let's go ahead and stop.